So we said that the base is going to be a general term, but the alkali is going to be a smaller term. Okay. So all the alkalis are bases, but not all the bases are alkali because not all the bases are soluble in water. So pH will be above 7. If we use the litmus paper, red litmus paper turns blue with the base. Metal oxides, hydroxide, carbonates are usually bases, means they all have the pH more than 7. And they all have OH negative or O negative ion somehow. So it means they are presence of OH negative is telling that they are the base or alkali solutions. Okay. So there is one base which does not have OH negative inside, but still it's a base. Ammonia. Ammonia in the form of solution, not separate. Ammonia solution means NH3 ammonia with water, which is called ammonia solution. Ammonia solution is also a base. If you check the ammonia formula, it has hydrogens, means it should be acid. It can donate the hydrogen, means it should be acid over here. But right now in the formula, we have NH3, but still it is base. It means it can produce hydroxide ions when reacted with water. How? So basically, when NH3 and H2O react, they produce NH4 positive and OH negative ion. One of the hydrogen from the water will go to ammonia. So NH3 will become NH4 positive. Okay, now you can apply both the definitions that we did already. We said a base is something which can accept H positive, right? This was one of the definition of the base. A base is something which can accept H positive. So here NH3 ammonia is accepting H positive, accepting one hydrogen from the water and making NH4. And we said that a base is something which is producing OH negative. So OH negative is produced in the product side. So both the definitions are applicable even in case of ammonia solution. So ammonia solution is behaving like a base, but in a little different way. All other bases are simple. They have OH in the formula. That's easy to identify. Only in case of ammonia, it is ammonia solution. So ammonia can take H from the water. So it is a base. Ammonia can give OH at the end with water. So it is a base as well. So both definitions will be applicable over here. So again, remember the difference between ammonia. Ammonia is a gas with NH3 formula, but ammonia means NH4 positive is present. If we talk about these two words, aqueous ammonia and ammonium hydroxide, these are basically, it is the same thing, two different names for the same thing. What does mean by this? Just write it with you. Aqueous ammonia means ammonia mixed in water. Okay. As we just said here, when ammonia mixes with water, it produces NH4 positive and OH negative ion. Okay. So we can also say it NH4 positive or OH negative ion. Okay. Then we have ammonium hydroxide. Ammonium hydroxide, if you apply the ionic compound naming rule, the formula rules, you can see ammonium means NH4 positive. Hydroxide means OH negative. So again, it is the same thing. Then you can combine it as well. Exchange the numbers NH4OH. So this is NH4OH. This is basically also NH4OH. In the ionic solution, it will quickly join and make NH4OH at the end. So it is the same thing. Aqueous ammonia or ammonium hydroxide is basically the same thing, two different names for the same formula. Is it clear to everyone? Any question till here?
No, miss.
Okay. We can continue. After that, now we are going towards preparation of the salt. Very first thing is we can make a soluble salt. We will see two methods for making soluble salt. This is going to be your method number 1. Then we will check another method, method number 2, to make a soluble salt. Then we will see one method for making insoluble salt as well. So these three methods are very important. and they can give you any example in the exam, and they will not ask you, or they will not tell you that which salt is soluble or insoluble. You will just go back to the solubility rule table, and you will identify the produced salt is soluble or no, or whatever they are asking, is it soluble or no. So solubility rules will help you here. Okay, so let's start with the very first method of the salt preparation.
Miss, I have a question.
Yes,
So
sure.
basically, preparing a soluble salt, like you're doing it. It was insoluble and it became soluble, or you're just preparing soluble salt.
No, we are
Like
just
any.
making soluble salt
Oh,
from
okay.
some reactants. So we will see
Oh,
what
okay.
reactants are needed. So we are making just soluble salt at the end in two methods. Reactants can be any reactants. And we are making one insoluble salt by using some different reactants. Okay, so for this first method of preparing a soluble salt, if we want to make a soluble salt, we need two reactants now. Number one, we need an acid. Number two, we need a base, but the base should be insoluble base. For this method number one, remember, number one, we need acid as a reactant, any acid. Number two, we need a base, but the base should be insoluble base. So react these two together, and this will give you the final product as soluble salt. Okay, so now here, because the base is insoluble, insoluble doesn't mean that it is unreactive. Maybe someone will have this question in mind: if it is insoluble, how it will dissolve with acid? It is not dissolving with acid, it is reacting with acid. So insoluble doesn't mean it is unreactive. Insoluble means it is not dissolving in acid, but the insoluble base outer layer will easily just give out the OH negatives that will just go and react with acid. Here the acid will give H positive. Okay. This base can give OH negatives, so they can easily react with each other. Okay, to make this type of the salt, we are going to take the insoluble base in excess, and it has a reason again. And we are going to take this in excess, and the reason is why insoluble base we are taking in excess. The reason is because, let's say, we have some amount of acid which is going to react with this base. Let's take an example. Let's say we have an acid. It is reacting with insoluble base, and it is making a salt at the end, a soluble salt at the end. Okay. And side product is going to be water with it. Okay. Now they said we are going to take this insoluble base in excess. Let's say if you don't take in excess, then what will happen? If you don't take this insoluble base in excess, if you take this in limited form, let's say you're taking this limited. Limited means this is going to finish early. This will finish early. There will be some acid remain inside. Okay. So then what will happen when you are going to perform all the experiment? You will be getting the salt at the end, and this remaining acid is there. You have salt at the end and remaining acid is there. You are going to do the filtration process. Then you will do evaporation process. You will evaporate the water from the solution. Only soluble salt and acid will be there. This acid, because of evaporation of water, will become so concentrated that it will make the solution very dangerous and explosive. It will go dangerously concentrated by evaporating the water. So this will be a risky reaction. To avoid this risk, we need to finish this acid quickly. No acid should remain at the end. Getting the point or no?
So, Miss, basically, we add more base to prevent to make sure that the acid has went away and only water is left.
Yes, very good. So we are going to add excess base so that base will remain over there. No problem for the base. No acid should remain over there. Insoluble base should be in excess so that all the excess base can react with acid and acid will finish. And the reason is because if we don't use excess base, we use limited base, it will finish first. If it will finish first, acid will remain. That remaining acid is going to make the solution very dangerous, because when the water will evaporate at the end by filtration and by evaporation and crystallization process, that remaining acid is going to be dangerously concentrated. Okay, so we need this insoluble base in excess, and this acid should react full. It should finish early. Fully react. Only then this reaction will be safe to do. Okay, so this explanation is written here as well. If this step is incomplete, then unreacted acid would become dangerously concentrated during the evaporation and crystallization process. So we have to avoid this reaction. So we have to add excess of the insoluble base so that all of the acid has reacted. Okay, when all of the acid will react, excess insoluble base means it will remain till end. It is insoluble means it will remain in the form of solid. So it will remain in this soluble salt solution. We have to separate this remaining solid from the soluble salt solution. Any idea how we can separate? If some of the reactant, which is solid, is present in the final product, how we can remove it?
Miss, by filtration.
By filtration, yes. So now we can do the filtration to remove this excess reactant from here. When we
Miss, we're separating the solid from a liquid?
From the liquid, yes. See, we are reacting to reactants.
Okay. Yeah, I get it.
Yes.
Yeah.
One of the reactant is in excess and that is in solid form. When the product will form, this excess solid is also there in the product. So to remove this excess solid, we need filtration.
Yeah, I remembered, Miss, the definition of filtration, which is removing insoluble solid from a liquid. I remember.
Yes. So after filtration now, this whole solid will be separate. We will be having only salt and water at the end. Okay.
Yes.
So excess reactant is removed by filtration. So only salt and water will be left behind. Now, we want just salt. We don't want water. What we can do? How we can separate this salt, which is, remember, soluble. We are making soluble salt.
So it's soluble with water. Crystallization.
Crystallization. Right? Okay. Yes, Samreen?
Miss, I said crystallization, so Luna already said it.
Okay. So crystallization we can do over here. So in other words, we have to evaporate the water from here. So water can be evaporated by providing heat, but we are going to provide a little amount of heat only, not excess of the heat. It can basically decompose the salt as well. And there are two drawbacks I will tell you over here. If we are going to make, we have to heat it. We have to evaporate the water. How much? Until half of the water is evaporated and half is still left. You will stop heating. Let's say you have 100 ml of the water. What you are going to do, you are going to heat it. 50 ml is evaporated, 50 is still there, you will stop heating. Remaining 50, you will just keep it at room temperature. Remaining will evaporate slowly over a period of days. And that is a good thing. Just leave the reaction for a few days. It will evaporate slowly in some days. And you will get final salt in the form of crystals. Yes, Luna.
Miss? Don't we have, I remember in the process of crystallization, don't we have like the process that when, hold on. Yeah, when the, when we have evaporated the water, okay, already, and crystals are left, we just pat them down to remove the water, and then we have ready crystals instead of waiting for several days? Like, why are we doing this? Why couldn't we just pat it down?
I will tell the reason why. See, first we have to heat the water, only half will evaporate, half will remain. Then we said this half will evaporate slowly at room temperature over a period of days. Okay. Now there are two reasons for this. Number one, when you just heat it slowly, like not fully, it will help you, or it will prevent the decomposition of salt. Decomposition of
Oh.
salt. Decomposition means the salt formula can break, salt can burn, salt can change the color, salt can change the composition if you keep heating, keep heating. So we have to stop heating after half of the water is evaporated to prevent the decomposition of salt. This is the reason number one. Reason number two is very interesting. And that is, if you stop the heating when half of the water is evaporated and remaining you do slowly over a period of days, you will get large sized crystals. Large crystals. And large crystals are more important than small size crystals. If you just quickly heat, evaporate all the water within few minutes, you will get very, very small crystals in that case. If you want small, you can heat it fully. But if you want large crystals, then we will slowly evaporate over a period of days. Okay, let me show you one of the picture over here with large crystals of copper sulfate like this. Very clear and big crystals will be there if you slowly evaporate in few days. These will not be there. We will be having very small and rough crystals if heating will be very fast. Plus the blue color can also burn and give you dark color or maybe black color if crystal will decompose at high heat. So these two are the benefits and reasons over there. And if carbonate will be used in place of the base, we said that we are using acid with insoluble base. It is making salt and water. Insoluble base can be metal oxide, metal hydroxide, maybe metal carbonate. Just like we said before, that base can be of three types: metal oxide, metal hydroxide, metal carbonate. If this insoluble base is going to be metal carbonate, then there will be a third product, carbon dioxide gas as well. Then there will be soluble salt plus water plus carbon dioxide. But carbon dioxide will just leave quickly in the form of bubbles, no problem. So remaining whole process will be same. Okay. Any question till here?
Miss, can you repeat what you just Miss? My internet just
okay.
my internet just went away.
I just said that if we have acid and it is reacting with insoluble base, making a soluble salt and water. This insoluble base can be of three types. It can be metal oxide, it can be metal hydroxide, it can be metal carbonate. If it is metal oxide or hydroxide, then it is soluble salt and water as a product. But if it is going to be metal carbonate, in that case, there will be a third product as well. And that is carbon dioxide.
Oh, just
for the carbon dioxide, it will just quickly leave in the form of gas. So no problem. All the remaining steps will be same. This gas will evaporate. No need to separate this gas. It's already separated. Okay. Just bubbles will be there. We can see the bubbles and we can identify there is a carbonate. So same is written here. If a carbonate was used, then carbon dioxide gas will be produced. One of the example of this type of the reaction is given here, and that is when we have copper oxide in the form of solid, H2SO4 aqueous. Okay, so copper oxide, what is this? Is it acid, base, salt, what?
As base.
Base. Because copper oxide means it is metal oxide.
Metal oxide.
Metal. O means oxide. So metal oxide means it's a base over here. Okay. Can we say it alkali?
Depends on its solubility.
See the solubility. State symbol is given.
Solid.
Copper oxide is solid in the solution. So it means, is it soluble in the solution or insoluble in the solution?
Insoluble.
Insoluble. And yes, we are saying that we need insoluble base. So this is basically insoluble base. So we cannot say it alkali. Here, if you use in the exam the term alkali, take an insoluble alkali, react with the acid.
No
No
marks.
marks. Okay, because we said alkali is something soluble base. So copper oxide state symbol solid is telling you it is insoluble. Plus we are telling in the title, in the very first line, that we need insoluble base. Means we cannot say it alkali here. So copper oxide is not alkali, it is just base. So this base is reacting with acid, H2SO4, and producing this salt here. Okay, now this salt is soluble or insoluble? Check the state symbol. Aqueous
Soluble?
means what?
Soluble, miss.
AQ aqueous means solution in water. So it's a
Soluble.
soluble salt.
Already soluble. Miss,
Yes.
and we said from the first line that that it will produce soluble salt.
Yes. So if let's say they are not asking you in the exam, or they are not telling you about this method, they're just giving you this equation and ask you to identify which method it is, or identify them. So you can say, okay, copper oxide is a solid, means it's insoluble base. Reacting with acid, making a salt aqueous means it is making a soluble salt with water.
So
Easily you
prepare.
can identify by checking the state symbols.
So basically, miss, we will say the method is preparing a soluble salt.
Yes,
right?
from insoluble base and acid. Okay, so larger crystals will be seen only in the solution if it will be evaporated very slowly. Only then there will be larger crystals. Okay, yes, Samreen.
And miss, this will be a neutralization reaction, right?
This is a neutralization reaction because salt and water is produced, so neutralization reaction. So by checking the symbols, by checking the names, you can identify type of the reaction, neutralization as well. Okay, after that, the acid could be reacted with a metal. Simple metal we can use as well to make a salt, and hydrogen gas. That is also one of the reaction over here, that acid can react with simple metal, that we just said as the very first reaction of acid with metal, produce a salt and hydrogen gas. We can make the salt this way as well. But one condition is that whatever metal we are using over here should be above the hydrogen in the reactivity series. But we will not take the very first metals, sodium, potassium, which are like at the top, because they are too reactive. Okay, and that will give the dangerous reaction. Too reactive means very quick and fast reaction, explosive reaction. So that they will be hard to handle in the lab. So we cannot do very reactive metal reaction.
But miss, if we wanted to take an example in paper, like
yes,
on
it will
paper,
be correct.
then it will be then we can.
Yes, you can write. You can write that the sodium and potassium will react with acid, make salt and hydrogen. But you will say, if you want to perform in lab, we will not choose sodium and potassium because they are too reactive and dangerous. Reaction is possible, but reaction is little dangerous to perform in the lab.
Miss, we could wear astronaut suit and we can do it.
We can try as well, yes. Okay. And another exam question here, the same thing, they can ask you why solid oxide is added in excess, means the insoluble base. Solid oxide means the insoluble base.
Miss, can I say?
Yes.
Miss, we said we just wanted to avoid the unreacted acid, as if we found acid with water, it is very dangerous. As maybe if they used potassium, so it is very dangerous. We said it's very it's a risky thing to do, so we don't want that.
That's right. Perfect. Who else can say the same thing? Like why insoluble base is used in excess in this reaction? We have Samreen. Yes, Samreen.
Miss, the unreacted acid, like it will become too dangerous, and because it is so much concentrated, and when we do evaporation and crystallization. And miss, I had a question as well. The acid plus metal. So metal is a you can say, is this an insoluble base?
No, metal is not a base here. Okay, this one is not a neutralization reaction here. It is a simple reaction to make a salt. Here the metal is not like behaving like acid or base. It's just reacting with acid and helping the acid to make a salt. For example, if we take HCl here with a sodium metal, so Na can come and react with hydrogen, replace it, make NaCl with hydrogen gas. Then you can balance it as well. 2 hydrogen means 2 HCl will be there, 2 NaCl will be there, and 2 Na will be there, like this.
Yes. So, miss, this is a reaction to just make salt.
Yes, it's a reaction to just make a salt.
Okay, miss.
But if you need neutralization reaction, then we need metal oxide, metal hydroxide, or metal carbonate. All three will be bases. Then base and acid will be neutralization reaction. Metal
Okay,
and
miss.
acid will not be a neutralization reaction. Okay. Base and acid is neutralization, and base is metal oxide, metal hydroxide, metal carbonate only.